And the variables that are amenable to this measurement are called nominal variables or categorical variables. What you need to keep in mind, ladies and gentlemen, is that in a measurement scale, because as I have said, the computer understands only the language of numbers. And therefore, even if we have something like a variable as famous as gender, we have to find a way of specifying. This is a message for the ladies and gentlemen who are not aware of this. Okay, you have to tell the computer that gender as a variable can bifurcate into male and female, and we have to do this by using a number, because the computer does not understand any other language than that of numbers. And therefore, when I say, for example, for a gender variable, eye color, religion, city of origin, country, whatever, as long as we can distinguish between categories inside the variable, when I say gender, how many do I have? Child. Two.
It has been updated.
Two. I'm very conservative. Never mind. In Darija we have marons, so 1.5. Now we have. Okay, so gender bifurcates at least now, male, female, and the computer needs to know that this variable has these instantiations by assigning a number to each category. For example, if we give 1 to males and 2 to female, the understanding is that between but 1 and 2, while they do have that status of a number, are digits, they do not by any means have any mathematical value. There is nothing in M that makes it lower than F, and vice versa. Okay, in which case the number there is for taxonomic reasons, is for classificatory purposes. When we talk about eye colors, how many colors can we? Eye color. Brown, green,
blue.
Blue. Yeah, there you go. Black, yellow. Yellow. If you have if the person has hepatitis C, left. It's malicare en français. Okay, nice. So when you have these things, so you give 1 to black, 2 to white, 2 to yellow. This is a good example of a categorical variable that has instantiations, and the numbers there are not by any means significant. Number 2, the second scale. We go over this very quickly. So when you feel that I have exhausted the minutes, you feel free to tell me. With the promise, third promise that I will, I will be present for another session if need be, right? Depends on. Never mind. Okay, so the second measurement scale that we can talk about is the ordinal scale. And in an ordinal scale, unlike nominal scale, in ordinal, in English, we have cardinal numbers, we have ordinal numbers, we have first, second, third, fourth. Okay, so when I say first versus second versus third versus fourth, do the numbers have any value here? For example, if you say the first, let's say, Sidris number 1, Arak number 1.
Like a verbation class.
Idris number 1, Amrus number 2, etc. Then Idris number 1, Amrus number 2. Between 1 and 2, the difference between 1 and 2 is not like the difference between male and female. When I say that there is something in you that makes you, that have better qualities than Amrus, for example. Okay, so this is ordinal. Very quickly, we can use this in the questionnaire. This comes up. This type of measurement is imposed on us when we talk about an agreement scale, for example. Strongly agree, neutral, disagree, strongly disagree, and I would like to open a bracket here and say that in designing a questionnaire, try not to use numbers that are even. like 2, 4 in your scale. You know, and this is what we refer to as a Likert scale. Likert scale means 5, 7. 5 is the ideal, but it's the one that is oft used. Is so for those of you who are not familiar with this, it's Likert, l'échelle de Likert. Okay, Sulam Likert. Okay, nice. So the idea is that in a nominal scale, the numbers do not mean anything. They are there just like color, just for isolating categories. In an ordinal scale, the numbers start to acquire this mathematical value. Number 10 is not like number 8 is not number 7, and so on and so forth. Having said this, let's move to the third. We have only 4. The third measurement scale is known as the interval scale. What is the difference between ordinal and interval? Notice that the measurement scales, you know, can be understood better by looking at the weaknesses of each. Okay? You know, so the difference between this and this is that in an ordinal scale, let's give a concrete example. Let's provide a concrete example. Just imagine we are in a classroom and we have assigned, we are in back the grades. Students, Mrs. Msaoudi, for example, got an 18. I like that because you were hardworking. My class, she gets an 18. No, sorry, gets an 18. Tabish, is that Tabish?
Yes.
Okay, Mrs. Tabish gets a 15, and Mr. Amrus, for example, gets a 9 or an 8. When I say that you are, you know, Mrs. Msaoudi is the first, Mrs. Tabish is the second, Amrus is the third, you see, the difference between the points is not the same. So the nature of this ordinal scale, you see, measurement, is that the points in on scale are not equidistant. That is to say, between the first and second, the distance may not necessarily be, as it is between, third and fourth and fifth. You know, you can find, different,
intervals.
Intervals. That's very interesting. The different intervals. In an interval scale, on the other hand, the points, that's what distinguishes them, the points are equidistant. For example, we can see this in the age groups between 15 and 20, 20, 25, 25, 30. We can impose this type of measurement on ours. Is that fine? Sure. Good. The fourth one, I'm going over these very quickly, so I apologize for those who are introduced to this for the first time. The fourth one is what we refer to as the ratio scale. And what makes the ratio scale different from the interval scale is that in an interval scale, the 0, when you have 0 here, this is an arbitrary 0. What does that mean? It means it's not an absolute 0. Again, an example will do better. Yes or no?
Sure.
If I assign a test here about your motivation, a questionnaire to elicit information as to how motivated you are. And just imagine that I score this over 20. You see? Mm-hmm. And for some reason, one of you, for one reason or another, obtains a 0. Does this mean that in reality, the person who scores 0 on a motivation test, or let's say, let's be more concrete by given the example of a reading comprehension test. Please forget about motivation. Reading comprehension, that's better. One of the students gets a 0, maybe because he did not paraphrase very well and he missed the synonyms, and the teacher decides to assign a 0. Does this mean that the student in question does not have the comprehension skill? Or does it mean that he has the skill, but on this test he happened to fail? Do you understand?
Yeah.
So the 0 is not absolute.
Yeah.
Another example could be, we have some teachers among us here, when you assign a general English language test, And some students get a 0, especially if the test is multiple choice and for one reason or another the student happens to get a 0. Either because they don't revise or they close their eyes and they ticked and we don't know. Can we conclude with any confidence that the 0 score that the student has obtained is equivalent to 0 knowledge in English? At least he knows how are you, he knows yes or no, knows how to conjugate. He can even sing some songs, he can imitate an actor, an actress, whatever. You see? So this means that in an interval scale, that's the point I am making, in an interval scale, the 0 does not reflect the reality. Does not reflect the reality of what is being measured. Nice? And this lacuna here is replenished by the fourth scale, which is what we refer to as the ratio scale. Ratio scale. Ratio scale. If the interval scale is not associated with an absolute 0, then the ratio scale should be associated. It fills in this gap. Okay? And the things that we measure by means of this scale, you know, we can, in the course of, you know, measuring something using this scale, a variable, then the 0 has the real meaning of a 0. A good case in point is when you try to weigh yourself. Some of you weigh 70, others 60, and so forth. Others more, you know, but as we go down, you know, the human being maybe can, you know, the weight can vary between, an adult can vary between 45 if he is emaciated to, I don't know. And then you can take, for example, a cat. A cat's weight can vary between what and what? Well, you can take a rat. That's not good for the ladies, perhaps, because they are afraid of rats. And never mind, that's a bad example, but I'm sorry. That's how I can make you understand this. A rat can weigh between maybe a kilo or even less. And then you take this pen here. It can give you a number. And if you have a very, very precise scale, digital, for example, very, you know, like gold, a ring can weigh something. An earring, a very small thing, can weigh something. But when you have 0 kilo, 0 gram, let's say 0 microgram, what does that mean? It's the absence of the quality being met. It means there is no weight, there is nothing. You understand?
Sure.
Another example can be, you drive, some of you are drivers here, yes? When you drive at 120 kilometers and there is a sign telling you that you should not exceed 100, and then you slow down, you know, you get into a village and then you run you go at 50, at 40, at 30, at 10. Is the car moving? 10. 10. Is it moving? Yes or no? Then at 100 kilometers per hour, is the car moving? Yes. Well, at 0. 0 means it's not. So this is a good example of the absence of the quality being measured. Wrap up. Let me go over these very quickly and then move to cut to the heart of what we are supposed to talk about today, right? We are moving from a measurement scale which is very weak to one that is very strong. In a nominal scale, the number does not have any real mathematical function. In an ordinal scale, the number has a mathematical role to play, but the points between, it serves the purposes of ranking, but the points are not equidistant. The distance is not the same. And this, as we corrected here, in the interval scale. In the interval scale, you have points that have the same distance between them, but unfortunately, the 0 here is not absolute. And again, this is filled, this gap is filled by the ratio scale where the absolute 0 corresponds to nothingness. Is that fine? Great. Now that we have introduced these, this concept of measurements. I know that you know now the difference between the independent, the dependent. I guess that that I should not say anything. Perhaps apart from the idea that, because that has implications on the way you enter your data in SPSS. By the way, SPSS is a software that is so intelligent that it can perform complex operations in a fraction of a second, but at the same time it's so stupid that it cannot do anything on its own. Therefore, the bulk of the task falls on you in order to avoid what is commonly referred to as the gigo effect. ماشي gigo اللي أظهره. You know that? There is a gigo there. الطريقتين حديث, الميز and volume. You see? Now the gigo effect, let me write it here. Gigo. You have to avoid this gigo here. Gigo simply means if you feed your computer wrong data, you will get wrong results. G here refers to garbage. Garbage in, garbage out. So you have to be very careful. Don't rush into entering, the data, and unless you are sure of how you do it. And the first thing we would like to start with is, yes, thank you, Sigalina, for preparing this. You know how to enter the data on SPSS? Or in SPSS? I guess you have no problem here, which makes our task easier. Nice. Allow me to sit down. Now, I have given you a couple of examples here of good comparisons. By the way, the good comparisons, you as a researcher, thank you very much. Unless you are involved in some sort of relationship among your variables, unless you are involved in the investigation of a relationship between X and Y, because if you do this, then you have, you should consider running correlation, Pearson correlation or Spearman rule, it depends on the classical assumptions. Or if you are measuring impact, then probably an easy way of doing it, a direct way, an accessible way, on this basis at least, is the regression analysis. Okay? Otherwise, is aware of this, factor analysis, and you have the structure equation modeling, which is a little bit complex, but this will again depend on the type of research question and the research variable that you have. Ladies and gentlemen, let me tell you something. That's a piece of advice. Because I have been here for around 14 years, and I have been working with master students and doctoral students, and the mistake that is committed among students, among researchers, is that they are unable to summarize, their studies, their theses, in one sentence. They don't know the objectives of work. The first thing you have to worry about, even that may take you months, I'm not exaggerating, you have to know your objectives. You should first know what you are working on. Otherwise, there is a risk that you are running that your thesis will be incoherent, your study will be incoherent, your study will not find attraction by anyone, and you will be criticized vehemently sometimes. When you have objectives that are that go east and analyses that go objectives, research questions, hypotheses. For those of you who are still at their early stages, do your best, ladies and gentlemen, in collaboration with your supervisor. Check with him or her, and with the people you know. There is no harm in discussing, with the people you know. Okay, so that you will be clear on these. The title, yes, the title can still be modified later, but a hypothesis, research questions, objectives. these are the backbones, backbone of your research, because everything else will depend. Even your reviews, even if your doctor review cannot be random. You know, a review has to be focused and has to cohere with what you mentioned in your objectives. I insist on this because so many students spend 6 years on their theses, but when you ask them, and this happened to me, I told my master's students, I guess, there was a story behind that, and a lady who spent 3 years on her work. When I asked, she wanted to check, somebody sent her to check, you know, so I could have an opinion, give her my opinion about it. When I asked her what objectives she has, she couldn't provide me. She wrote a lot. I guess she gave me 100 and something, you know, part of the review and instruction, but with no objective whatsoever. She was talking about everything, but at the same time, it was talking about nothing. And she started crying. I said, this is not a solution. Try to get down to your work and try to give it something. Do not be involved just in reading and summarizing. That's not research. That's a summarizing job. That's not research. Ladies and gentlemen, having talked about this, I'm sorry if I'm too talkative, more talkative than I should, but I think it's for good cause, yes or no? Okay. Now for group comparisons, as I said, in quantitative analysis, when your thesis adopts a quantitative approach, a statistical approach, then depending on your research questions, hypotheses, and so forth, because these dictate the type of statistical measures that you will adopt. You see, you can either be involved in a design which analyzes relationships. For example, if you have the ER statements, the higher, the lower, for example, the higher the student's motivation, the more likely they are to perform in writing, you know, for example. The more anxious students are, the less likely they are. So you have correlations that can be positive, negative, that can be, you know, that can be positive or negative. Never mind. But you can also be involved in a comparison task. And this is so broad, this term comparison, group comparison, is a very broad term. And its breadth stems from the idea that there are a number of options for us. That's why I say we may not finish the whole thing here today. Group comparisons can start, you know, we can talk about, as a basic illustration of group comparisons, group 1, group 2. You know, the literal meaning. You know, you teach 2 groups, and you have 2 methods, and you want to try one method, whether the traditional method is effective or the new method, you want to introduce a method. Then you have group 1. Group 2, you administer a test later on after you have taught one group, you know, in a different way than the first. You know, this is what you refer to as a post-test, and then you compare. Whatever differences you find between the 2 groups, it can be imputed. There is a likelihood, we will not be absolute here, there is a likelihood that it is imputed to the new teaching method. This is one way of comparing groups, okay? And in inferential statistics, group comparisons, you know, deciding, I'm repeating this idea, deciding to get involved in a design, to adopt a design that compares groups, will be dictated by your what? Objectives, hypotheses. You see? And later on, you can make further decisions as to which group comparisons you will be following, you will be adopting. That will depend on the, number 1, the nature of your variables. Nature of variables. Nature of your variables. Do you have nominal, ordinal, or scale variables? لاحظوا معايا. For SPSS, we have, you know, for the ratio scale and the interval scale, they are referred to as scale. Okay? We will see concrete. We will check the concrete here. Concrete example. Okay. So the nature of the variable will guide you to the type of, you know, statistical group comparisons that you will be conducting, and of course the type of which one is dependent, which is independent. You have to notice this. All right? And how many levels each has. Before I illustrate this, on the computer, I would like just to let you know that in statistical analysis, in inferential statistics, there is usually a distinction between what we refer to as parametric statistical tests and nonparametric statistical tests. Parametric statistical tests are supposedly more powerful than their non-parametric counterparts. And because they are more powerful, they have to satisfy certain classical conditions, certain classical assumptions. Okay? For example, if we intend to compare group 1 and group 2, or a group of males versus a group of females on the amount of talk per day, does this need research in the first place? Okay, the amount of talk, then we have to know, we should make sure that we have a categorical variable that has 2 levels. So, if I'm comparing X and Y, males and females, automatically, ladies and gentlemen, automatically, I coined this in my class, in the classroom, masters, in class, when you are comparing X and Y. Ladies and gentlemen, comparing X and Y on something, comparing males X, females Y, comparing Rabat, Casablanca, that's X and Y, yes or no? Comparing Jamal Ahmed Amros, that's also X and Y.
Perfect finding.
All right, okay. When we do this, keep in mind, ladies and gentlemen, keep this in mind. X and Y, automatically, one of the available t-tests. It's a t-test. Another way of, maybe you can remember this, is that t may be 2. T refers to 2. Okay? Not in reality. You see? Okay. It's a t.
10 more minutes.
Thank you very much. Yes, that's more. I have a feeling that we probably need more say about this. Okay, the t-test. The t-test, just for you to know, we have families of the test. Or we have maybe, this is a cluster of tests actually. We can distinguish between 3 types at least. One sample t-test.
2 dependent samples.
Independent, thank you. Independent
Samples.
samples, we need an S here, samples with S. And then the paired samples, let me say something briefly about these. Yeah?
Sorry, I'm saying, I thought they were the same, but not.
No, they're not the same. No. One sample t-test, as I said, as long as it is called a t-test, it means that there is a comparison between X and Y. Fine? You may not be familiar with this. One sample t-test means what? I'm sure you have grandparents or family members, the elderly among your family members. Some of them suffer from what we call osteoporosis. You know that? Osteoporosis. اللي هو هشاشة العظام. You know? I discovered this fortuitously in reading a medical report that my late mother got from a doctor, and I found out that you are using this to calculate, to decide whether the individual has osteoporosis or not. You see? Because the World Health Organization has figures that are standardized, that are, you see, for example, the individual whose bone density is, for example, 0.35 more, let's say, if it is close to this, then it's normal. You see? But when it significantly departs, it's far from this, then it's osteoporosis. So, one sample t-test is when you have is a comparison between the numbers you obtain in a group by means of your effort. You collect data, you do the calculations, you have the mean, and the comparison with something that is standard, that is given. You understand? So what we have is, we have a number on the one hand, and we have the group on the other. How many samples? We have just one sample. You get the point? This is different when we compare group 1 and group 2, where you have independent samples. You know what one sample is? There are some universities that require a certain GPA, you know, the score, GPA, in order to access a given university. And the GPA is not really absolute. You can go beyond it. You can have a GPA that is lower than this, you know, to some tolerable, you know, extent. But if you are too far, you do not stand chances for being accepted. And this is done by means of one sample test. There is a standard score given by a given university, and then there is the score of the sample, the individual, or another individual, or even a group of individuals. You know, for example, if there is an exchange, whatever. You know, this is one sample test. Independent samples means that you draw your data from two individual groups, and they are mutually exclusive. Mutually exclusive. That is to say that when you assign a score to this individual, this score is independent of the score of the other individuals. They are separate. They are independent. Male and female. When you give 10 to a male, you will not give the same score to a female. You get the point. You cannot have people from the other group, you know, be enlisted in the other in the group of males. For example, you can't have females. You collect scores maybe from females, and you list them with the males, and vice versa. The scores have to be independent. The observations have to be independent. This is what we refer to as the independent samples t-test. Paired samples t-test. Paired samples t-test. What is a paired samples t-test? Again, in an independent samples t-test, we have group 1 and group 2. Fine? Now, just imagine I have just a group of females here. Let's imagine that we have a group of females, and my intention as a researcher is to measure, for example, their score on a writing test for one group, females. But at the same time, I need to know their scores in speaking. I want to measure their scores in speaking and writing. How many groups do I have? One group. Females, one group. You see? You see? Or let's say, another example, just to illustrate the difference. In the undergrad program, we have linguistics and we have cultural studies. Yes? Now, if I compare the fluency in English, you know, if you compare them on fluency, if you compare linguistic students and cultural studies students on fluency, how many groups do I have here? And these, I have two. Now, that's a piece of research that can unfold in a way. Now, another example linked to this, just to establish the comparison, is now we focus only on linguistic students. And I want to know their score in syntax and in phonology. How many groups do I have? One. Linguistic. How many scores do I assign? Two. Paired. A pair of scores. Okay? So this is what a paired samples t-test is. All right? Now, having said this, there is one thing we need to know about these types of tests. It's a comparison between X and Y. Yes, but the condition here is that you have groups. That is to say, you have, especially here. Here the variable, the dependent variable has to be continuous. That is to say, has to be scale variable. Here and here, they have to be scale variables. When you want to run a t-test, an independent sample t-test, then the dependent variable necessarily needs to be a scale variable measured on either a ratio scale or an interval scale. And of course you need, especially here in the independent and the paired, you see, you need, no, for the independent you need a group, the independent variable has to be categorical with two levels. لاحظوا معايا t-test x and y. That's the t-test. T, باش تعقلوا عليها 2. Okay. When you have more than one group, for example, you have S1, S2, S3, S4. This variable is called academic levels. Fine? That can have different instantiations. S1, S2, S3, S4. How many levels does this variable have? لاحظوا معي, in gender we have only 2. You see? When I give you the example of literature, in cultural studies and linguistics, there were 2. These are amenable to a t-test analysis. Now, when you have S1, S2, S3, and beyond, we are no longer in 2 groups. We are no longer in X and Y. You see? So, when you have a group of multiple levels, then the statistical measure, the relevant measure, is the ANOVA test.
F-test.
The difference between the independent samples test and the ANOVA test is that in ANOVA you have more than 2. Fine? The occasion will come, inshallah, later on to talk about this thing. So I have 5 minutes or so?
3 minutes.
Less than that. Okay, I just would like to provide you with an illustration here. I would like to request some more minutes, please. There's something
How many more minutes?
3 more.
Please.
Yeah.
Please.
These are cheap.
Nice.
5 more minutes?
Thank you. All right, okay. You made my job easier when you said that you know how to enter your data in SPSS. Ladies and gentlemen, I want to, there is a mistake. And initially, remember Si Hassan, when I communicated my title to Si Hassan, the initial version of the title was The Do's and the Don'ts of Group Comparisons. You see? But I have talked about group comparisons, but I have not mentioned neither do's nor don'ts. But please, Allah يجزيكم بالخير. I have been a jury member, in a number of theses, master's theses and doctor's theses. The mistake that keeps recurring is that people rush into the analysis. They seem to love numbers. They seem to love, the sophisticated tables that the output gives you, but without making provision for some violations. Some potential threats to the correctness of the model, of the analysis. There are certain assumptions first. I used to call it, because sometimes we have these conditions of types of variables, groups, and so forth, but we cannot, because the data itself does not allow us, sometimes we are not allowed to run the independent sample data, for example. It's not that I have 2 groups, I have 1 continuous variable. This is independent sample. Yeah, go for it. No, it does not work like that, ladies and gentlemen. There is what we call a visa. You remember that? You need a visa. You need a visa, yes. Okay. The visa, that's just something I coined, and I'm grateful that my students liked it and got it. And okay, there is what we call classical assumptions, one of which is the normality assumption. You have to check for normality assumptions. Okay? 3 minutes. I will provide you with maybe the keyword here, and then I wish there would be another meeting for this.
You can also ask questions.
Yes, there are 2 types of tests that you have to run before you go to the main test, which is the independent samples t-test, I'm just focusing on this, but this applies to other parametric tests. You have to run normality tests, and the computer, the software, provides you with two types of tests. One of them is known as the KS, the Kolmogorov-Smirnov, which made one of my students laugh hysterically when he first heard that. I later discovered why that was the case. All right. So Kolmogorov-KS test, or the Kolmogorov-Smirnov, and then there was the Shapiro-Wilk. These two tests have the capacity of granting you the visa for the use of parametric tests like the independent samples test. How? The p-value, so small. If KS and Shapiro gives you a p-value higher than 0.05, determine 0.05, it means that the normality assumption is satisfied, and therefore you can run the test without any problem. If, on the other hand, it gives you a p-value of 0.03, 0.04, 0.02, lower than 0.05, it means that you are not granted the visa, and therefore you need to do something else, which is to switch into non-parametric tests like the Mann-Whitney test, and maybe other parametric tests like chi-square and others. All right. My dear friends, I wish I could extend this further, but I don't want to take from the time of my colleagues and from the nerves of Hassan. Okay. So I would like to thank you very much for your attention. If you have questions, you are more than welcome. Hopefully, we will have another session. I'm looking forward to it.